Stone softening acid and geopolymer. What the? G'day again, punters. Righto, we have a long one this time, full of information about the site of Sacsayhuaman in Peru, near the city of Cusco. Please enjoy this presentation and be sure to follow the links in the description below to subscribe to the original content creators. Now sit back and enjoy.
Situated next to Cusco in the Inca heartland of Peru, Sacsayhuaman is one of the most incredible ancient structures in the world. It's truly mind-boggling how such enormous blocks of stone can be so randomly shaped yet so perfectly put together. These are large blocks of limestone, sometimes huge, most of which seem to pillow or bulge out instead of having straight sharp-cut faces. Some blocks seem to curve around corners, others have scoop marks on their faces, and a number of them have the famous nubs. Each block is irregular, and each one is unique, yet the joints between these limestone blocks are perfect. So how is it even possible? Some speculate there was a type of stone softening agent added that allowed the limestone to be moulded. Others believe that each block is actually man-made from some kind of geopolymer mixture, whether cast in moulds or just worked into giant lumps of a dough-like substance. Others speculate that these are actually cut rocks, but that some kind of high-technology instrument was used to make and shape them. The quarries for these grey limestone blocks are believed to have been located. It is pretty much accepted by all. So, this does imply the blocks were cut from their natural setting and brought to the fortress. And, as some of the blocks weigh more than 150 tons, this feat would be truly incredible. But I am very sceptical of high technology cutting tools for ancient construction projects. Because if such tools did exist, how did they manage to evade the archaeological record on every continent of the world? I just think that by now we would have found something. Detailed petrographic work has taken place on the blocks of Sacsayhuaman. There are at least 9 samples already analysed from across the site, as well as a comparative study to samples taken from the associated quarry, the proposed origin of the stones. The stones were deteriorating. Large cracks were opening up in the main walls. We see the shifting of stone blocks and the recession of walls. This could well have led to irreversible change to the site, and so, 9 years ago, under the guidance of the Ministry of Culture of Peru, geophysical and geological analysis was undertaken by a team of Peruvian, Russian and Ukrainian scientists, employed by the Ministry of Culture to get to the bottom of the cause of the damage. You can see here the wooden frames that were added to keep the walls stable, which is really quite a worrying sight. It was found that the movement of water beneath the walls was destabilising the foundations of the fortress. The soils were fissuring. So, a variety of samples were taken for geological testing, including a microscopic look at the geological microstructures, the characteristics of the rocks, the chemical composition, and so on. The first and most basic test was to find out the rock type, which was assumed to be limestone, something we all say today, and seemingly confirmed by the fact that a sample completely dissolved in vinegar. The company Geo and Associados SRL and several geophysicists from the VNI ISMI Institute of Russia, headed by Dr. Andrei Veryanov, carried out a study on the subsoil of the Sacsayhuaman archaeological complex, with GPR scanning technology and a surface study of the blocks on behalf of the Ministry of Culture in Peru. As well as geologists in the field, a number of Russian laboratories were involved in the analysis, again, all credible companies, including the Institute of Tectonics and Geophysics. Samples were taken from carefully selected places across the site and were looked at in thin section under a microscope. The limestone from the quarry is an organic limestone, and it is made from marine microorganisms, a natural rock where you can clearly see many fossils, just like with many types of limestone. There is no doubt that this is a natural rock. But the sample published in the study from Sacsayhuaman is different, in that it is made from 1 to 10 micron calcite crystals, which was confirmed by phase X-ray analysis. There are also veins and lenses that are filled with thicker zones of crystalline calcite. There may be a few traces of fossils, but these have all been recrystallised. But the official report states that traces of natural fossils, microorganisms and microstructures of the limestone are gone. So, in hand specimen, the two rock types do look very similar, but they are very different under a microscope, yet the samples have a near identical composition. Because of this, scientists concluded that the blocks of Sacsayhuaman have to have been made from limestone from the quarry, because the chemical composition is too similar to be a coincidence. But if that's the case, the stone from the quarry has been processed. It's changed from a sedimentary rock to a fine crystalline rock. The scientists said in their official report that it's impossible to be a process of nature. That's the opinion of a team of international experts. As they state, in nature organic limestone can be metamorphosed or recrystallised into marble. But marble, even the fine-grained variety, has a larger crystal size than what we see at Sacsayhuaman. Here the crystals are minute, and the structures in the block are uniform. It's a homogeneous rock without fossils or stratigraphy. The scientists go on to discuss how an acidic environment, like the acid content in rainwater, will dissolve the blocks of Sacsayhuaman little by little over the years, and they recommended a protective coating be applied to the blocks. So this was the first and main revelation. The blocks of Sacsayhuaman are not taken straight from the nearby quarry, yet they do have the exact same composition as the limestone in the quarry. They are also apparently not just heated or metamorphosed by nature because the grain size is too small to be a naturally formed marble. As stated, the experts concluded it was impossible to be a process of nature. They believe that material was collected from the quarry, was pulverised and ground, and used to make a mixture to create blocks. So, in summary, they said there were two types of blocks in the Sacsayhuaman archaeological complex. Type A are the low-density, large blocks of the first level. These are made of a number of rocks, but with the shell of the crystalline substance that covers them. The experts believe that these blocks were made in this way so they could receive as much weight as possible. They were scanned with georadar, and the interior is not homogeneous like the other blocks of Sacsayhuaman. The smaller yet still big blocks above are Type B, and these are made entirely from the fine-grained microcrystalline substance, the same substance that forms the shell of the larger Type A blocks. It is a legitimate piece of work that was done by reputable people working directly for Peruvian authorities. The following year, in 2013, another paper was released, this time by the ACIDA project. The ACIDA project paper was written by Alexi Cruiser and is titled The Question of the Material Origin of the Walls of the Sacsayhuaman Fortress. This happened either late in 2012 or early 2013, just after the official report was presented to the Ministry of Culture in Peru. It's 17 minutes long and explains the origins and background of the project. For now though, I'll pick out some key points. At 3 minutes 51 and 3 minutes 55, he shows the quarry rock samples in thin section, and we can see the fossil shells and the limestone matrix. Around the 4-minute mark, he shows 4 samples taken from the stones of Sacsayhuaman. He says, fine microcrystalline limestone, almost not even limestone, but more like marble. However, marble in most cases is macrocrystalline with large crystals. But here we have very finely crystalline limestone material. In some cases there is this vein running through it with larger material. At 4 minutes 42, he shows a picture of normal masonry blocks, but running through them is a trough or channel. He explains that this is unnatural. He classifies the rock that makes the fortress as being a very fine microcrystalline calcite. And again, after showing the compositions, it is clear that the rock of the quarry and the Sacsayhuaman blocks are the same material, but somehow we see totally different types of rock. As he states in his conference, his opinion and interpretation of the geology was that the ancient Peruvians quarried the limestone and ground it to a fine powder, and then roasted it to get quicklime. Then, after mixing it with water, they poured their blocks. One man stands up in response and says it's just natural limestone laid out in a conventional way and dismisses everything that's been said to him, which does seem strange in a room full of geologists and also based on the presentation just given.
Tell me, what kind of pouring could be the result of what is seen in this area here? This is all natural limestone laid together using a conventional method.
Another guy then stands up and explains he does agree with Berdnikov's conclusions, and believes that these blocks must have been made from a lime-based solution, and that the transition from the solution to the rock appears to be very rapid, as is seen by the tiny size of the crystals. He agrees there is likely some missing additive in the mixture. He says that maybe it's something to do with the conditions in Peru, low water saturation, or a certain temperature regime, which allowed for the rapid crystallization to take place. This conference leads us nicely into the ACIDA project paper, which does take this work a stage further, although in a more speculative way, to try and offer a more scientific interpretation to the results. According to the scientists, the shiny, sometimes vitreous surface of the Sacsayhuaman blocks is all down to the percentage of silica in the mixture, which makes it look like it's been polished. The silica is also what makes these manufactured blocks ring like a bell, as shown in this video by Geotech. So, the science here does seem on point. It appears as though it is very possible that the blocks of Sacsayhuaman were made from hydraulic lime, which would have come from heating Peruvian limestone. At Sacsayhuaman, there are of course a lot of blocks, which means we are looking at industrial scale manufacturing of hydraulic lime. Remember, the temperatures required were between 900 and 1100 degrees Celsius. Therefore, for the Sacsayhuaman rocks to be made by human intervention from an artificial hydraulic lime paste, the ancient people would have had to quarry the limestone and then heat it manually. And we know that bonfires can reach extremely high temperatures if skillfully made. Special ovens could have been made, with wood and coal being the fuel. We've seen how fires from warfare affected Iron Age hill forts across Europe, reaching extreme temperatures and actually melting hard igneous rocks like basalt. But the main problem we have for the blocks all being made from a man-made mixture is the incredible volume of this mixture that's needed. It would be a truly enormous industrial scale operation. Was there even enough coal or trees? How was the rock crushed? Where is the evidence of huge amounts of burning in the archaeological record? Why is it not seen in sediments? We should find enormous deposits of charcoal and ash. We lack the evidence for the production of man-made hydraulic lime, and the scale of the operation does seem unbelievable. Wouldn't it just be easier to extract, cut and shape limestone from the quarry? We can all argue over how the megalithic walls of Sacsayhuaman were made, but we can't argue with the science. And when we compare the rock samples from the so-called source quarry and the samples of the blocks that make up the fortress, we see the complete disappearance or dissolution of organic remains and the apparent recrystallization of natural sedimentary limestone, whilst maintaining the same composition as the natural limestone seen in the quarries nearby. But after releasing the official report to Peruvian authorities, to give him credit, Berdnikov did find a natural way the rocks could have been formed, and it's detailed in the ACIDA project paper. Yes, the blocks of Sacsayhuaman could be quarried stone. The initial claim is not right. These blocks are not impossible in nature. You can get the recrystallization of limestone in a natural setting if it was subject to intense heat. So the limestone in the region would have had to have been exposed to some kind of lava extrusion, coming through the natural bedrock limestone formation and then spilling out on top. This would have created the high temperatures needed. And what do we have right in the vicinity of Sacsayhuaman? The famous Rodadero Formation of Cusco, an ancient extrusive silica-rich lava flow that once pushed through the limestone bedrock and then flowed out onto the surface as well. Anywhere below ground or on the surface where the limestone and lava came into contact, the limestone would have been cooked to very high temperatures. The Acida project paper says the limestone would have been transformed into a type of lime. This lime would then react with rainwater, hot spring water, groundwater or water vapour, and the naturally formed lime would then recrystallise into a type of contact metamorphosed limestone, a type of microcrystalline marble. A sample of limestone was taken in the field right next to the famous Rodadero formation, but I can't tell if it's a block or bedrock. But this was shown to be the same rock type that makes up the wall blocks of Sacsayhuaman. I should add that geologically speaking, the Rodadero formation is millions of years old and not recent. For the people that built Sacsayhuaman, they would have come across the incredible looking natural lava flows of the Rodadero formation, and it would have been surrounded by recrystallised hard glittering limestone. So, it's not really a surprise that the rocks associated with this natural wonder would have been selected to build Sacsayhuaman, with its hard, strong and dense natural properties. In my own honest opinion, I do believe the Sacsayhuaman blocks are completely natural, and I think it's even proven by the petrographic work by Berdnikov. As we can see, some thin sections show there are calcite veins running through the blocks of Sacsayhuaman. In the veins, the grain size is larger than the bulk of the rock, but in terms of geology, veins occur when hot fluids travel through zones of weakness like fissures, and then cool over a period of time, and that's what forms the crystals. The longer the cooling time, the larger the crystals. Therefore, how can you have veins of calcite running through a man-made concrete that was seemingly made from pulverised stone? The fact is, you can't, and therefore, geologically speaking, the blocks really can't be man-made. But I think there is another even simpler way to explain the blocks of Sacsayhuaman naturally, and it would mean that the man that stood up in the conference to say that these blocks are just natural limestone is in fact correct. Because you can have a carbonate-rich, microcrystalline limestone rock that forms naturally and without the addition of heat and recrystallization. The specific rock is called micrite. Micrite is a crystalline limestone made from calcareous particles ranging in diameter up to 4 microns. It is a carbonate rock and it's dominated by fine-grained calcite. The word micrite comes from microcrystalline calcite. And how do the Russian scientist describe the rock that makes up the blocks of Sacsayhuaman? Yes, he calls them microcrystalline calcite. It is in fact a sedimentary rock, but has crystals instead of grains simply because of how it's formed. It is not some kind of metamorphosed marble. It is a sedimentary rock. When hardened, the rock looks grey, dense, uniform and fine-grained, just like we see on the blocks of Sacsayhuaman. As stated in the book Carbonate Sequence Stratigraphy, some samples of micritic limestone have been found to ring like a bell when hit with a hammer. This is due to how dense and hard the rock can be, which is compact due to the small crystal size. Micrite can also fill cavities between grains, rocks and boulders, like a natural cement, and therefore there is a natural explanation for the agglomerate nature of the large blocks of the basal layers of Sacsayhuaman. So, the man who stood up and dismissed the claims by Berdnikov may actually have a point. He could actually be right on the money. So, where did the stone come from? Well, I think I do have the answer. One of the 10 samples comes from the quarry and is clearly a natural organic limestone. This is the natural rock, and you can see that it does have many features and structures in the matrix, and many fossil shells are clear to see. The other 9 samples come from Sacsayhuaman. Deputy Director Berdnikov PhD from ITAG, the Institute of Tectonics and Geophysics in Russia, noted that 8 of the 9 samples were the fine crystalline calcite stone, but one sample, sample number 4, is questionable. Sample 4 is actually a missing link. We can see outlines of shells and organic material, but set inside the same microcrystalline matrix as the other samples. The addition of fossils is intriguing, because it implies we're looking at a natural rock, whether having undergone some kind of contact metamorphism or not. It clearly has a different nature to the sample from the quarry. but that's because this block of stone would be from a different part of the wider depositional environment. Electronic microscopy and microanalysis was conducted on this sample at Rostov University, which revealed that the majority of this rock was fine-grained calcite, as well as grains of quartz and feldspar. There were grains of iron oxides and also crystals of potassium chloride. The university deemed this surface to be natural. They next looked at an unprocessed surface of the rock sample and found that it was covered with impurities, dust and modern organic matter. Interestingly, particles of copper were also discovered. The copper may well have come from a tool, indicating that this sample 4 did indeed come from a conventional worked block. Thermal analysis also indicated it was likely natural. But what of the other 8 samples from Sacsayhuaman? Do we learn anything else? Well, yes we do. Specimen 8 is taken from an outcrop of a natural rock formation. Yes, on top of the hill that is surrounded by the megalithic walls of Sacsayhuaman, there are in fact natural outcrops of limestone. Specimen 8 was described as fine crystalline limestone with no traces of organic residues, and there were signs of recrystallization in fissures. Sample 9 is also not from a Sacsayhuaman wall block, but comes from a partially cut limestone block or maybe a worked outcrop at Coca to the north. This is right next to the Rodadero formation. This too is described the same as sample 8, both being the same type of rock that makes up the blocks of the walls of Sacsayhuaman. So, whether the Sacsayhuaman blocks are natural sedimentary limestone rocks or limestone altered by the heat of the extrusion, the geology certainly tells us that the blocks are natural because there are natural outcrops of the exact same rock type in the vicinity of Sacsayhuaman. Furthermore, the fact that some samples of the blocks contain mineralised veins is a clear sign that they are not man-made moulded blocks from some kind of lime mixture. All the blocks were likely cut and quarried on site, maybe from the top of the hill, or maybe on the slopes, or the area surrounding the Rodadero formation. Looking from above, we can see that this whole region has been worked by humans, so we don't know exactly how it looks before Sacsayhuaman was built. But all indications from the geological work says the blocks were cut in situ. They were not brought to the site. Originally, the scientists involved in the mineralogical work offered one interpretation of the findings, a man-made origin, but the natural interpretation in the follow-up paper, as well as my own interpretation that they could just be micritic limestone rocks, I think are certainly more likely. The man-made interpretation would require incredible amounts of quarrying, pulverising, grinding, burning, moulding, shaping and transportation and so on. Then you also need a huge amount of wood and coal. You also require storage facilities, specialist equipment and tools, trained workers to make the blocks, and also handle the possibly dangerous lime-based chemicals and more. You could do all of that, or you could simply quarry natural rock from the construction site, craft it into boulders and then work to join them together. The latter option, although more mundane and still difficult, is easier, more efficient and far more likely. In fact, there is even irrefutable evidence that at least some of the blocks were worked with conventional tools. These blocks were taken from one of the damaged walls during the geophysical survey of the site, and as you can see they are covered in tool marks. And as we see with sample 4, copper is also present on the surface of the block, likely from ancient tools.
Historical records credit the design of the fortress to 4 architects over a period of years: Hualpa, Rimachi, Maracanchi, Acahuana, and Calacuntri. It was begun in the reign of the great Inca empire builder Pachacuti, or perhaps his son Thupa, in the mid-15th century CE. See these smaller stones filled in here between the large ones? You may sometimes see on the internet people arguing that the Inca could not have built this fortress, and they point to these stones as evidence. They say these smaller stones constitute Inca repair work, and therefore the larger stones must come from an earlier period. But by simply asking around, doing some reading, or looking at old photos, A proper researcher would realize that these smaller stones are modern repair work and not from Inca times. Ancient Architects noted this on his channel.
This stonework we can see here is modern renovation work, laid hundreds of years after the Inca period, and this was done to tidy up the site. You can see it all along the walls of Sacsayhuaman. This is shown when you compare the 1930s image with the modern one side by side. You can clearly see where the walls have been built up recently with inferior stone, to stop soil creeping down the hill, to protect the site and make it safe for tourists.
How much do the heaviest stones weigh? So we're going to close up and just highlight. So we have three particular stones of interest, and especially the middle one is the one that gets the most attention. Here's the aerial view, and just to show that area, so it's right at the lowest tier where there's essentially three tiers. The lowest tier is where all the largest stones are, and therefore the heaviest, but how much do they really weigh? So here we have the main one that's often photographed, mentioned, especially Lost High Tech type videos. This is calling this one Cheech, the big stone, all right? Now we have a guy there, so I'm going to estimate that he's 6 feet high, probably being, I'll be a little bit more generous when it comes to these things. So we can get stack him on top of one another, stack him across the bottom. So we get an estimate of the size. So it's 16.25 feet or 4.95 metres high, 16.75 or 5.1 metres wide. But it's not a perfect square. So I'm just using this checkerboard, 10 by 10, and with that, so without the correction it would be 25.245 square metres, but approximately 90% of it should be removed, so that's putting it at 22.97 square metres. So let's just call it, round it up to 23 metres squared. There we have Cheech, 23 metres squared on the surface, and we have another big stone, Chong, and there we can see that stone there. And in the background we have a fellow walking, so I'm going to again assume that he's 6 feet. But because of the perspective, he's further back than what these stones are, so we're going to correct for that. So turn him sideways, so he's 6 feet. However, there is a perspective going on, and so what we have is that these stones, and I'll cover it more because I want to show you in coming up videos what they look like behind. So the stones are not very wide. So essentially what we have is the stones are about 1 metre wide along the length. So when you see these big blocks, such as Cheech here, well, he looks massive from the front, but think of it more as a slab. It's relatively thin. So don't think in 2 dimensions when you think about weights of stones, because you have to know the 3rd dimension to get the volume, and then you can work out just how heavy they are. So 23, but it's 1 metre thick. Based on the stones above. The stones are not deep, the big ones. Now it could be, I'll come back to that in a moment, but based on the rest of the structure, they're not going to be very thick, so it's 23 cubic metres as well, because it's only 1 metre thick, approximate. Now, how much does limestone weigh? Well, 2,711 kilograms per cubic metre, so 2.711 metric tons per cubic metre. These stones, again, they're not andesite. Again, if you think Wikipedia even lists them as andesite, what they are is limestone. So granite, again, is slightly less in weight than what is limestone. So granite is 2.69 tonne per cubic metre. Limestone is 2.711 tonnes per cubic metre, and basalt is heavier than that again. But this is not granite, this is not basalt. These blocks are limestone, and they're also quarried from a short distance away. Okay, so there we have Cheech. Well, Cheech the stone, not the person, all right. 23 cubic metres, 2.711 tonne per cubic metre, so we have 62.353, which is 61.36 UK long tons, 68.7 short tons in US, but this stick just to show those, because maybe when I say tons you're thinking tons and US versus UK, so let's stick with the metric, 62. Now this Cheech, which is often referred to as 130 tons, could be 132 tons, but then it would have to go over 2 metres back behind the wall, and that just doesn't seem to be the case based on any of the other stones there. Why that should be an exception, it shouldn't be. Cheech the stone and Chong the stone. Okay, so now we have this is Chong now, a side, one view, and from this view we can see it from the other side. So with that we can start working. We can now assume that, sorry if you're shorter, Dave, I'm assuming you're shorter than 6 foot. But I'm going to assume that he's 6 feet and use that as a reference. And so again, we can work out the height, 20 and a half foot or 6.25 metres. And we can work out the width at 10 and a quarter feet or 3.12 metres. So we go to the side. Now, this guy in the yellow shirt and blue hat, again, he's standing again from the camera the same distance, so we don't have to worry about perspective again. So we've got the measurements on that side. Now we look closely and I can use that to work out that stone is, let's call that the depth of 9 feet or 2.74 metres. However, so that would make it 53.43 cubic metres. However, the stones are not rectangular. And so now I'm going to put, this checkerboard is 10 by 10. So I've shrunk it in, but we still 100 rectangles in each one. One side is about 80 out of 100, 20 being left, and on this side it would be about 15 out of 100 of those rectangles left. Split the difference, let's say it's 20% or 15, so I'm going to say it's 17.5% overall, which means we can reduce the, if they were blocks at those dimensions I showed, it would be 144.8 metric tons. But it's a little bit over 80% of that, so it's 119.5. I'm just going to round that off and say it's 100 metric tons. So okay, we have 62 and 120 metric tons. Go back to this composite, and I want to highlight, I want to look at this cornerstone here in the back. The next one down. There it is, close up, because this one we can get a rear view, and I'll get back to this in it, but just in short, these were not cast. These are natural raw stones, because the smooth pillowed pattern on the out, well, that must be cast. Well, look at the back of the stones, they're rough as. This is not formed work, these were not cast, but you also get an idea of the shape. So turn that, now if I invert that and put it over, you can see how that fits over. I'm certain that's the spot where it was. There's a few other clues in the background, but this is the rear view of this particular corner piece. But what's important is that behind this corner block, you can see it's rough. So it's missing volume. So on the outside, again, I try to make, working on, they're not rectangles, so you have to take away the curves and all those other features, and especially behind. I couldn't get a good photo behind of Chong, but based on the other ones, and I'll show more of those in the upcoming video, the rear of the stone's just, well, it's sort of rough. So this 120 metric, so Chong could be less than 120 metric tons, because that back corner might be missing. And this is not just one example. I did a video series on Alante Tambo, and so for instance, the largest of the monoliths, it gets overestimated in weight, 50 or 60 or even higher. It's at maximum prop 42, because when you see the stone from behind, you can see how there's basically a whole quarter is missing from there. On the outside it looks like a rectangle, all nice sort of sharp corners, but from behind it's missing a lot of volume, and that would take away from it. So this is not just a one-off, this is a part of the style of the architecture. What you see at the front, very nice. What you see at the back, not so well. So we go back to Chong, and he's about 20.5 feet, 6.25 metres. Here they say the largest stone is 28 feet high, weighs nearly 200 tons. Well, forget this thousand. There's some typo, or I don't know what's going on there, but this 28 feet high number comes up a lot. So we go and zoom back and get an aerial, like a sort of semi-aerial view. That's Chong at 20.5 feet high, and along the whole length, they're all of the same height, and there's only a couple of like single monolith stones. So Chong and the one that I just showed you, the view from behind, the rest of them tend to be multiple pieces or with a large monolith but with a smaller piece on top. So no, none of them are 28 feet high. No, all right. But now let's look at, so there we have Cheech, there we have Chong, now we have this stone. So are there any nearly 200 ton stones? Well, there could be. So again, this is again Cheech. Now there, you can receive a pathway. There's a little entrance and a staircase that goes up to a second tier. That's the entrance point. Here is that stone. There's that staircase. You can see him going in and take a sharp corner. But okay, how big is this particular stone? This one might be a contender. Here's a top view of that stone. So it's got width, it's got size, and there we have a front view. So there's Cheech, there's Chong, and I'm going to call this one Dave's Not Here Man. Alright, so how's Dave's Not Here Man? Alright, zoom in a little bit, bring the other pic over, and again you can see in the bottom corner how it looks from the top sort of down. So there's quite a bit of substance to this particular stone. Now there is a person standing right there, so we can use that as a reference, as a gauge, and I'm going to be very generous, and so just to highlight it's the side view. So now we have a front as well. Now I'm going to assume that that person was 6 feet, and I think I'm being very generous there. So again, we're going to be very generous. So it's going to make it about 15 feet high, 18.75 feet wide, and 10.5 feet deep, 2,950 cubic feet, or 83.6 square meters, cubic meters, sorry. Very generous, and again remember limestone 2.711 tonne per cubic metre. So this could be 225 metric tonnes. However, I think I'm being very generous here now. Again, a 1 by 1 by 1 metre cube block. If I make it 1.25 wide by 1.25 high by 1.25 deep, I've doubled the volume. So only by adding 1/4 to each of the three axes, I've doubled the volume. So a small change, and I think I've very exaggerated the height, width and depth of this, would make a dramatic change in this. So I think, like, I'm being super generous. Could be as half of this weight that I'm showing here. So, but I just need to be a bit more accurate with that, but let's include it. It is a possibility in there because this person might be 6 foot there in the background, but highly unlikely. So it's all assuming that they're 6 feet. A small change in dimensions can, pardon the typo, cause a large change in volume and therefore the weight. But there's another issue with this particular stone because I'm not just by the erosion and the patterns that are in there. That's one clue. I'm assuming that this stone was moved. I think it might be actually a natural stone. Possibly could have been quarried and moved, but I think that this might be a contender for a natural stone because incorporating natural stone into architecture is just an Incan trait. Try and find somewhere that doesn't have it rather than look for a place. So here's a collection from the David, but again, I'm just going to show you some various photos from Machu Picchu, Tambo Moche, across the Inca Trail. The Inca always embedded natural stone into their architecture. It was just a common feature for them to do this. So again, so you see there, which is very unusual compared to any other civilization stone building one. They basically flattened the site and then built on top of it. But the Inca, for whatever reasons, not only incorporated it but sort of featured it as an important part of the building. So again, you can see just different examples bringing in the bedrock as part of the structure. Machu Picchu, so again, some people go, well, how did they move that rock? Well, this is what the Inca did, incorporated bedrock a lot. Again, you can see two examples there. That's just directly underneath this part here. It's at Machu Picchu. Again, you can see, I think this one, is bedrock, but again you can see it over here on the side. Again, people like these now, just a natural bedrock. Inca did it a lot. Again, that's find an example that doesn't have it. Would be everyone has it. There might be some places here or there that don't, but it's just a natural thing for them to incorporate natural stone. Just was their style. So, for instance, here, and this is a concrete block that was put in place. Now, while I'm here, you can also notice nice polygonal fitted stone on the outside, rough work on the inside. This is the nice stuff goes on the outside, and I'll come back to that as well because as a separate video. Anyway, let's keep going. Just again, Tamba Moche, again, including the stone in there. So that's what I think is happening in this particular stone. Also suspect, but because of the nature of the wear and sort of tear on this stone, but this might have been actually, that they've opened that up. Pure speculation on my part, and I'm only speculating that this was a natural piece, that it very well could be. Again, a bit more research required. All right, so we come back now a little bit further down where you see this amphitheatre. There is a large stone there, and I couldn't get the dimensions of that. That is a contender for being 200 tonnes. But these are ifs, but Cheech over here, he's not 130 tonnes. He's 62, and this one would be much bigger, 120 tonnes, depending on the back corner might be missing those pieces like I showed at Alante Tambo, and so that could be even less.
Hi, I'm Mike Haddock, and today we're going to do a little review on Sacsayhuaman, which is in Cusco, Peru. I visited the site. As I said, our family's been in business over 70 years. I worked as a stonemason all my life, and I'm going to give you my take on it. All right, I'm going to do a 360 here, so you get an idea of this site. And the Coliseum part is over on that side. And the parking lot down here is down below where you come in. So we're looking down at the layers as they go. And they put these little ropes up anymore, just like if you're down. But they made these awful tight. And they did have earthquakes in the area. And what I found out is just by looking at it, they're not all perfect going right through. There's a lot of different variations in them, and they didn't worry about the face of them. They just put them in. Now we're looking at the back of the stones. They're not carved perfect in the back. They don't care about the back. It's in the sides when they want to get them up to each other. Again, when they're putting their stones together, they do this part good. They don't care about the back. Back don't matter. Now we're on top of the fortress, and those stones ain't cut perfect. And even in the back, they're not cut perfect. They cut them, and they might have stopped there, but you can see all the backs of the stones. It's not like they say it's almost like the Coral Castle. I don't really see that much of a difference. Again, here's some of these huge stones. And on the top, they didn't care what they did on the back side of them, because the back side was going to get covered with dirt. Here's some of the stones. You could actually go see how they squared them and cut them, but they're all not square. They all cut them to fit in a certain position or a certain place. Right off of this Coliseum thing, looks like they got other things where they carved into the stone. Same kind of thing. And right over there, looks like a little quarried spot again. I'm looking at this stone, and it's not straight. You see there's like a little bend in it. We get down to this one. That's pretty straight, but still not straight. I'm going to talk about that site a little bit, and as a stonemason, I don't see as big a deal as everybody says it is.
First of all, when I first got out of the service, I was working for a guy who was moving houses. When we would use the house jacks and get it up on rollers and actually move the house. And if we were short a jack, we would just get 2 wedges and a guy banging on each side with the sledgehammer, and up the house goes. So moving those big things is not a big deal to me. There's other stuff on the internet that people's moving big stones. I did a video on the Coral Castle, and that's before they found that lost footage of the guy moving all those big stones by himself. So if someone's saying to me, Mike, how do they move them big stones? Well, you start out moving a little stone, and you start learning how to move a bigger stone, and you start learning how to move a bigger stone, and sooner or later, you figure all that stuff out. That's not a big deal to me. As far as carving the stones, I did the video on Ollantaytambo and Machu Picchu, and I made that little reference that if you want to find an easy way to do something, always get the laziest guy and he'll find the easiest way. And I want to thank all the engineers and architects who wrote into me thanking me, saying that is the truth. That's what you do. So I hope you enjoy these videos. To me, it's not a big a deal as everybody says it is. They might have used different techniques in ancient times. The stones could have been softer or whatever. You can make your own theories up. It doesn't matter. So thanks for watching. Until next video, I'm Mike Haddock, and that's it.
But okay, I saw this guy, and this is what inspired this video. This is some pretty good polygonal masonry here. Unfortunately, it's just a little short, and I've got small clips of it, but it's enough to go off of. Then you've got a pretty trick little V-notch right there going in. And this is some quality craftsmanship. He's got really tight fitting joints here. And this method scales up. If you can get these complex shapes onto a 1-foot stone, you can get it onto a 5-foot stone. You can see his scribe marks on there. And there's basically 2 parts to this. There's laying out the stone, and then there's stone cutting itself. You've got to be able to transfer that shape onto the stone up above and then cut it. So first, stone cutting. In order to get a flat surface, they use a clawed chisel, and you're just carving these 1/8-inch grooves into it, and then you come back through with a flat chisel and flatten everything out. But this is Charlie Gee. He's got a channel. He's a young guy in his early 20s, it looks like, and he's already a master stonemason. I'm telling you, freehanding that straight line right there, that's pretty impressive. On the rough end, he's just busting off big old chunks, then he gets out the claw, and then gets out the finished chisel. And I know this is marble, it's soft. You're not explaining granite here. You got to give me a minute. I can only explain one thing at a time. But the majority of buildings or cathedrals are either limestone or marble or sandstone. And marble is just limestone without any seashells in it. But here you see the V-shaped claw. That's how you set your depth. And then you get out a flat head and smooth it all out. That's perfectly flat and straight there. And then he starts rounding it out. And that's just setting the shape up in order to carve in his intricate details. When you get down to the last stage of this, you're just sanding it smooth and then polishing it. But here he is with a rasp. When you see really fine detailed work like the fishnet, they didn't carve that out. They sanded that out. They rasped that out. Today they use machines to rough out the overall shape, and then the mason does all of the intricate work. Back in the day, an apprentice would get the block all set up and get the majority of the material out of the way. And I'm sure I could learn, you could learn how to carve a flat block. It's all about technique. But you got to be gifted artistically to be able to do things like this. Our most sophisticated robots today, with all our computer technology and machinery, but even with that, you're still just carving out a squared edge. It's a rotating bit. So you can get it 99% of it done with a machine nowadays, but the last finishing touches have to be done by hand. That's the gold standard. That's what a robot is trying to emulate, is the human hand. And trust me, when you do something day in, day out, you get good at it. This guy is just freehanding a circle and winds up being a pretty well perfect circle. The majority of stones that we actually build with and use on a massive scale chip and break just.
I was, as you know, I'm an architect, and I practiced for a long time up in Jackson Hole, Wyoming. And I was trained back east at Princeton. But when I got up there, this was back in the early 60s, they were still building a lot of stuff out of logs, log cabins. And I watched the old log scribers put logs together. And I said, wait a minute, these guys are scribing these logs together, and they get a perfect fit every time. No trial and error involved. They take a lumpy shaped log and they scribe it onto a lumpy shaped log down below, and they roll it into place one time and it fits. And if it doesn't fit, all the other guys give them, hell about it. The boss fires them and hires a different scriber. And so I said, well, that's exactly what the Incas were doing with big rocks. I wonder how that process could be transferred to big rocks. And that's where the idea came from. And of course, scribing is a well-known technique. It's even still used by people that aren't building log cabins. For example, if you have a stone wall in your house and you want to put a nice bookshelf or a cabinet next to it, what the carpenter will do is on that side of the wood construction, he'll leave a fairly wide board, and then he will take that construction, set it against the stone wall, and he'll take an object very much like a draftsman's compass, and it has a point on one end and a pencil on the other, and except it will have a level on it so that it's always in the same orientation and space. And he'll just run that compass down the face of the rock. He'll run the pointed end down the face of the rock, keeping the level bubble centered. And the pencil will then draw precisely that pattern of the face of the rock on that widened board. And then he just takes his jigsaw and he cuts along that pencil line and slides the construction against the wall, and it fits perfectly.
Well, what if you're fitting, something with three? Well, what would be three sides that they have to worry about?
Yeah.
So, well, if they did it with stone, how would that work?
Yeah, let's start with the lowest course. The first course at Sacsayhuaman, you've seen pictures, and all the joints between the stones are typically kind of long, more or less straight vertical joints. And that's where the biggest stones are, by the way, typically, except at the corners, and that's that's a structural matter. They're put at the corner because that's the weak point in a zigzag wall, and so they put the big stones there. But anyway, the lowest course at Sacsayhuaman is these large stones fitting together on these more or less vertical straight joints. I'll call them eye-shaped joints. And in that case, that's the easiest way to imagine using my method on stones. If you take two of those stones and set them far enough apart where several guys can work between them, the first thing you've done, of course, is you pick two stones that are kind of the same shape to start with, because, again, you want to chop as little as possible in order to make the fit, right?
Yeah.
Okay. You set them next to each other so a couple of guys can work between. And then what you do is you start chopping away those faces so that a simple stick, that is initially a slightly longer than the longest distance between the stones. And you chop away at those two surfaces so that no matter where you put the stick, it exactly fits between the stones.
Ah.
Now the ends of the stick have to be the stone at the ends of the stick have to be the two stones, the two pieces of the stone that are touching when you slide it together. So that tells you that the stick, just like the carpenter's compass with the bubble, has to be kept level and straight. You can't wobble around. It's got to have the same orientation and space at all times. So you make it a fork stick, and on the fork you put a plumb bob. That keeps it from going up and down from end to end.
So that's how they did leveling before the modern level was invented.
Exactly.
Yeah.
And I found plumb bobs. I have one here I found Inca plumb bobs. They had them all over the place. And you also have to keep it from rotating around the plumb line. And you do that by starting at the outer face of the stones, cutting an edge joint on each stone, and then carefully measuring in from that edge as you go back, so that the distance back to each end of the stone is always exactly the same. And if you do those two things, and you do this very, very carefully, you only have to move the stones one time.
That's right, yeah. And it should fit, right? Yeah. And then you just go side by side down the lower course like that.
Right. Right,
Yeah.
exactly. And the other thing to keep in mind with this method is it doesn't make any difference whether the surfaces are flat. In fact, the surfaces probably won't be flat. They'll have a certain warp to them that follows the original irregularity of the stones. You know, so
But isn't it
so
harder to do one on top because you
yes,
can't put the stones side by side?
right. That's where you get into the hard part. The scribing method is exactly the same, although in that case you have to scribe the rising joint and the bedding joint at the same time. You can't do one and then the other. And what that means is you have to, instead of your scribe being in a horizontal position, your scribe is in a diagonal position, roughly at 45 degrees, so that you go down the rising face and just go right around the corner into the bedding face. Meantime, keeping the same distance from the face and keeping the plumb bob straight.
It'd be just like if it was a curved side, I guess, or
exactly.
Yeah.
Exactly. And that's why if you look at those L-shaped joints, the corner at the bottom is always a round corner. It's never a square corner. You hardly ever see a square corner in Inca work. In fact, that's a whole other subject, but we can get into that later.
Wouldn't you have to hold the rock up above the
that's
other
the
rock? So what would you use for that?
The rock has to be placed so that you can use the scribe in that orientation. And the way you would do that is you would suspend the stone, the next stone, even the big ones, above and to an offset from the side of the rising face of the seat that you're trying to create below. You would pre-shape the upper stone, and then you would prop it up in that position. And the way I showed it in my original paper, the one that you've read, of course, it looks pretty unstable, and nobody wants to go under there and do anything, let alone chop away at any of the stones. And
so you came up with a better idea.
Yeah, well, yeah, the better idea is that you have a retaining wall at the back of the joint, and the rear of the stone that you have suspended is supported on that retaining wall, and only the front edge, the edge that will be exposed when the job is done and the wall is backfilled, the front edge is what's propped up on the log posts. And that's the other thing at Sacsayhuaman. If you look at it carefully, you will see many of the stones have sort of computer-sized square or slightly rounded pockets along the lower faces of the stone. Many of them just have a great big overhang on the lower face of the stone. And so all of those features were places where the tops of these posts could support the stone in this position. This is my theory anyway. And people often say, "Oh my God, those stones are too heavy. That couldn't possibly work." Not true. You take an 8-inch, 10-inch log on end, it will support thousands of pounds. I mean, wood in that configuration where it's not being bent, it's just being compressed, is a very strong material. Even softwood like lodgepole pine that we had up in Wyoming, it's 1,000 pounds per square inch. Well, you take a 10-inch thing, you're talking thousands of pounds, 50, 60,000 pounds of supportive weight. And there are usually at least 3 or sometimes more of these posts underneath the front edge. Actually going through getting it there and putting the posts in place and then taking them away at the end and then finally lowering the stone, all of those things are tricky, but they're not, for people like the Incas that were clearly very good at messing with big rocks, they're not undoable at all. They're not difficult. They're just, you have to do it right.
Very interesting. Yeah, that seems to be the most efficient way. Now, I guess they would get good at it enough where they could do it relatively quickly. I don't know. But
the thing is, the thing about it is that at least you're only moving the stones 1 or 2 times. You're not trying to move it, 30 times or 100 times or
right,
whatever.
Because that's the hardest
God knows
part.
how many times you have to move it to use trial and error.
Yeah, very interesting. It's a magnificent achievement, those walls, and it's the funny thing about it is it's so impressive. That's why people come up with all these strange theories about how the Inca couldn't have done it. But really, I guess you would say that the most difficult part would just be to figure out how to do it, not to actually do it, right? Yeah.
Right. Yeah.
Yeah.
Well, these guys were wizards at messing with stones. Stone to the Incas was a numinous material. I mean, it wasn't just a building material to them. That's why Inca stones masonry is not carved with all sorts of patterns in it typically, or it's not used like other people did. The stone itself is the point, and that's why they just left them raw, mm-hmm. or with their faces, and it's absolutely beautiful. Catch it in the right light and so forth. And they are totally unadorned stone walls, and yet they are absolutely gorgeous. When you get there, you look at them and you say, "Holy shit! Did these guys have their shit together, or what?" They did.
Yeah.
And you'll also find stones. Pisac is a good example of this, where they're building these walls right on cliffs. That where the face of the wall bleeds right into a 300-foot cliff at the bottom. And then the first row of stones perfectly fit into that cliff, and the rest of the stones go. So they didn't even have one side of the wall to work in, and yet they managed to do it. So these guys had serious stone working techniques and at their disposal.
That's just some of the basics of stone cutting. People have worked it up into this impossible thing, but still to this day, if you want something cut exact, you have a human hand do it. So I decided to experiment with laying out polygonal masonry. I've already explained how stone cutting works. You just have to get the shape transferred onto the stone, and then it's a matter of squaring it off. So now I'm going to show you how you get the shape onto the stone. And this seriously took no time at all for me to successfully transfer this onto the next block up. And that's using rounded edges and everything. Where, of course, if they're straight edges, it's a lot easier. And I know this is just some cardboard, but if you get the shape on there, then it's just a matter of squaring the block back, which isn't difficult. I mean, I literally just showed a guy squaring off a block with the claw chisel and then smoothing it out. But here's a very simple method for transferring it onto the next block up. Just imagine that this is a vertical wall, and you set a new block up on top of all these complex shapes. All you have to do is get a vertical line at each point where the angle changes. You need to do this extremely accurately is a plumb line, just a string with a weight on the bottom of it that's been around for thousands of years.
I'll be better off under a
string is still incredibly important on building any building. If I didn't care how long it took, I could build a whole house with a string and a gauge stick for all the layout. So here's how this works. We're going to transfer the shape of this stone onto the imaginary block that's sitting up on top of here. Get a vertical line going everywhere that the rock changes directions. I'm going to oversimplify things here and just use straight lines, but I was able to successfully transfer curves up as well. So you can take any size gauge block, literally just a stick, and as long as you're keeping it vertical, you can just trace your way across there. But just for the simplified straight lines, you put your gauge block on the first vertical line, you put the red dot. Then at the second vertical line, gauge block up, red dot, third, and you keep going all the way across at every one of the angle changes, you put a dot, and then you just connect the dots. Now the bottom face of the stone up above is perfectly shaped to the one down below, and then you just square it off. Just like Charlie was doing earlier, now you transfer those lines straight back square. Today we'd use a framing square like this. But back in the day, you'd have a wooden one set up like this. You've got two sticks there making the 90-degree corner, and then the one angled one to keep it square. That's all he's done with these blocks here, is you get it scribed onto the face. It looks like he had to adjust and slide over some, so you've got the mark that's about a ½ inch off. But honestly, I've built enough things that I already knew how to get it done. I just had to experiment with it a little bit. But within 5-10 minutes, I was able to get the shape successfully transferred over. And honestly, this would be easier on a big block wall, at least to move the shape up. I'm just doing straight lines here to show you guys, but on the bottom it didn't film very well. But I was just using the gauge block to trace the bottom, keeping it square and what would be vertical. And then once you've got it transferred onto the face, it's just like the guys earlier I showed you. You get to chipping. And then bam, there you go. Fits together. Square that off some to make the next block fit a little easier. Bam. And I know people are sitting there going, what, it's some cardboard. It got nothing to do with stone. I tell you, building stuff is building stuff. You lay it out and then you square up from there. I've built entire apartment complexes on the same principle. But honestly, this is not near as hard and impossible as people make it out to be.
And then consider how the stones are brought together, and we look at the stones that we can see the sides of them. All right, so focus on that one. Now what's happening with these, and this is still a method used today by traditional masons, is not to have too flat surfaces. So a lot of people look at, for instance, Hindu temples and, they're just blocks, but there's more going on there. They have subtle curves and stuff in there, and they still use this method of having a cup and saucer, so the underneath stone is concaved, so it receives the one at the top. On the outside it looks much nicer, but from the back it's quite rough. And so just that zigzag, we'll look at examples of that in a moment, but usually, not always, but the bottom is fit very well, but the side joints, only a small part, only that nearest the front, is actually fit very, very tightly. Okay, so as an example, this is what those giant walls look like from behind. So just as, so these are not cast, these are not form worked, these are just stones that have been fitted together, and you see, because this would be covered from behind, you don't need to make them look beautiful, and there are big gaps between. They're not fitted tightly. From the front you see those stones and it's got that, it look like these, but from the back it looks very different. Here's another example we can see from the back, from the front, again, that beautiful polygonal work, from the back, rough stone, and including, sort of large gaps in there. This is tambo mache, hot. So this is one example you see where even the top and the bottom are not perfectly fit. Only the front face is, and then the back of the stone is filled in with rubble to support it. Japanese masons dismantled one of these giant walls, put it back together. This is a method that they use. It's dry stone wall method, very common all around the world. Outside, beautiful. Once you go behind, not so much. Alante tambo, we can see the same thing. When you see from behind the stones, on the outside, this is cast, it's cement. Well, no, it's not formworked in cement, because again we see it's rough stone from the outside. If this was poured or cast, it would act like a liquid. There'd be no gaps anywhere, but they're all over the place once you look at the little details. Also at Alante tambo, again you can see from the front looks beautiful. It is beautiful, but when you look at the back, Machu Picchu has the same thing. There's been a bit of earthquake and subsidence, so these stones have moved apart, and we can see again from the rear what's going on. Rubble infill. In Machu Picchu there are freestanding walls, so this would be a retaining wall. There are freestanding walls where the front and the back is beautiful, because you can see both the front and the back, but most of this Inca stonework is retaining walls, and so from behind they don't need to be beautiful, they just need to work. So now we see the shape of this stone, and we also consider the side shape. So if I was to take this block and cut it along its height or across the horizontal, it's essentially going to be it's like a uniform shape. It's predictable what you're going to get. To the uninitiated, stonework's always been a bit of, it's one of those mysterious, like amongst all the old traditional crafts, it's the one that sort of invokes the most mystery. Now I'm going to tell you that they're using a stone softening plant, and now they're going to use this tool, and they're going to turn that octagonal piece into a column drum. They've softened the stone, and then they drag this around, and it cuts the stone. That's how they made the column drums, using this stone softening plant. Well, it's not the case okay now, but you could see people would believe that. Now, here they're going to fit this stone to the shattered block. So brand new stone, going to attach it to this shattered old stone, and they're going to use an acidic red mud to make that fit. Again, you could see how this would be interpreted for that way now. Barry's applying the... Now he's going to apply some of this mud, acidic mud, to do this perfect, beautiful fit as well. And again, V shapes in 3 dimensions, just so much more complex than those Peruvian walls. So look how they do that fit there, perfect. Did they use stone softening? Did they use an acidic red mud? Well, no, they didn't. So back to this Protzen. And contemporary quarrymen, speaking about people in Peru, dig up the root of ubiquitous bush named lawley, which has a deep yellow sap, and use this root for marking in the manufacture of paving tiles. So Peruvian, the ancestors of the descendants of the Inca, use this particular plant to mark their stone. None too different than what these people are actually doing. So these are Greek guys. They had a huge budget for this Parthenon reconstruction. Instead of using expensive engineering dyes, the traditional masons chose to use these plants to mark the stone. It's not stone softening, they use it for marking. And the people in Peru have a very similar plant, the lawley. Now, lawley, or the Bonadisia horrida, well, this is the plant that again grows all over the joint, all that around that part of the world. There's its range. High altitudes, lower altitudes, grows into quite a big bush. Thorny, used also as a medicinal plant, and also because of the thorns they use it to protect the fences. So planted along the fences, all those thorns stop the livestock from knocking them over. Machu Picchu, Ollantaytambo, Sacsayhuaman, but now north of Ollantaytambo we have Lawleyok, which again translates to one with the lawley. But this plant's it's an important traditional things going on there. Now Sacsayhuaman is another smaller site up here. Carretera, Lollipata, just trying to point out the significance that it's an important plant. There's alright, so this plant was being used, and probably still is, so very recently, by masons to mark out paving tiles. And I would I'd be very sure that they didn't just pick this up in the early 1900s, that this is probably a tradition which goes back to before the arrival of the Spanish. So how traditional masons fit incredible shattered stone together again, just way more complex than the it's not just 1 or 2 blocks, and it's not just a method that has just reappeared recently. You'll see in a lot of these old rebuilds, reconstructions, that this particular, we can see shattered stones put together. So they get the rough shape, then they apply this red mud, they get it to touch, where it touches, it's going to leave a mark on the mud. Well, that means it's a high spot. You take that away, then you test it again, find another high spot until eventually you get a perfect fit on a shape that's just leagues more. So you can see little white dots there. Yeah, now take those spots, remove that, paint it over again with the mud, test it again, and this is how they made these stones fit perfectly. Again, orders of magnitude more difficult compared to those polygonal walls. Using the mud, which have been traces of dirt, basically, dried mud in between the stones, and also the lawley. So I think that this lawley plant was the origin of the stone softening. People see the masons chose this or possibly another plant, but I think this one would be a good candidate. They saw it rubbing it on there, and look at this as the magic plant, and I would play this. I think a lot of tradesmen know what I'm talking about when the noobs come in, and it's like oh yeah, this is a magic. Look, it's going to soften the stone. Oh, this is our secret. Shh, don't tell anyone. And then the legend builds over time. Now, they're still using it to manufacture paving tiles. Now, there are paving tiles which are out on the street, which use like grout and mortar in between them. But you also find, beautifully fit paving tiles as well. So again, this is how to mark fit stones. This is a method. So firstly, you see the big stones. Well, how did they, move them back and forth and get them to fit using that particular method? Well, first thing would be is not to move the big stones, but to place them down. Start at the corner, put your big stone in between on the middle of the wall, and then fit the smaller ones to it. That would be the first and obvious step. Big stones such as at Sacsayhuaman are the rare exception rather than the rule. So, but how would you do it, 1,000 times? Well, you don't have to, because most of these types of walls are small, manhandleable stones. You wouldn't even need levers or that, just a couple of guys lifting them up. So there's like a handful of really large stones exceptions, but the rule is smaller stones such as these. One of the exceptions would be the 6 monoliths at Alante Tambo, but even those are not fitted together. So I've just marked them out, but we have a shim, 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 shim. So you get them close and you insert these pieces. So again, these are small, light stones that, again, a man could, a couple of guys just with, a lever, one guy and a lever could move. So you only need to fit those type of stones in there together. And because you could also insert them from behind, you don't necessarily have to drop them in from the top, but given them the shape that they have, they seem to be like where you could slide them in from the top. Anyway, okay, so when they show this one, well, how did they perfectly fit the stones? They didn't. They perfectly fit the little shims in between them. How would you fit the stones together? Well, the first step would be I got some clips. I tried to post them on YouTube as a compilation, but they got blocked worldwide. I can't show you them. One of the ones was blowing up history of the Machu Picchu edition, and they show stones halfway incomplete. So stones that are half processed, and you can see the method of how they were working to do that. I wish I could show you those. Vince Lee is one of the fellas to look up. All right, but with very simple scribe tools. So like a fork stick with a plumb line, the plumb line ensures that the stick stays horizontal. Then you can measure the distance between the stones, and when the stick doesn't fit because it hits a high spot, well, there again, you mark it, you knock that down, and then you keep doing it until you can get them to fit together. The sides of the stones, only the front part is connected. They're not all perfectly precision, touching each other to nanomillimeter perfection. That's just on the face of things. Scribe tools, there is a bit more modern versions, but it's a very simple concept. You measure the distance, you set the scribe tool, you run it along. When it fits, okay. If it's wobbling, it means, well, it's too big, we're going to have to reset, so that's not a good thing. If it doesn't fit, well, we need to remove a bit of meat and until it all goes along smoothly. It's not a very complicated process. It is a patient process. You have to be careful. If you make a mistake, well, you sort of have to not quite start over, but reset everything at least. Now we have a common, the so-called nubs or bosses, these protrusions that we've gone forward. We also have these indents. So here's some of the screenshots. I forget this fella's name. He's specialises at Machu Picchu, and he visits a few other nearby sites where you see half-processed stones halfway through the fitting process, and very similar to this image where they're propped up. They start the smoothing process, and sort of there you can see the nook, and this stone here is holding this larger one up, and this nook is going to fit into this position here. There's also stone rollers in examples such as this, so they can move the stones backwards and forwards and start scribing them down, fitting them together. So there are half finished stones where we can see the work again. That's in those documentaries. I wish I could show you those clips, but again, blocked worldwide whenever I try to post them. Question of lifting. The blocks never need to be lifted by a giant crane. When people think about moving big things, they just instantly go to a giant crane and they're going to deadlift it up. You don't need to do this, and this you would only lift with a crane like this unless you really have to, because it's a dangerous, risky thing. How would you do it? Well, here's a video of some bored German teenagers. There's a big block on top of a bank. They just undercut, dig underneath it, undermine it, lever it from behind, and they send it over the side. This would be one of the ways you could do it at Sacsayhuaman. So those giant stones, you bring it in from behind, essentially because the wall, it's earthen wall behind. Get it close to where you want to. Dig underneath one side. It's going to tip forward. You place your stone that way. Looking at a few questions. Now, was it a fortress? Was it ever completed? Looking at methods of the construction or telltale signs that are left in there, but compared back in the day. A lot more trees and such, but so the questions, was it ever completed? Was it a fortress? Wall section 7, if we do a tracing. So again, we can see that this section is very rough on top, unfinished, again indicating how the method in which the stones were built. You fit the bottom and the sides, then you would bang these out, the shape that's left over, then you would fit the next stone on top. So Jean-Pierre Protzen, the fortress of Sacsayhuaman, was it ever finished? So just like we saw in sections 1 and 2, we'll see in other places as well, this is one of the really strong evidence that it was never completed. Okay, now back on the northern side, on the second tier, part of a wall has collapsed, and it shows you what is behind. And again, it's this reinforced, so it's basically a hidden wall behind the wall, compacted earth. That's what's supporting the wall itself. Those walls, including the heavy stones down on the bottom, and the heavy stones are really on the ground level. Above it, they're relatively small. They would just be pushed over. There's no mortar bonding them together. They're not pinned in. There's nothing holding these things up but gravity. And if it wasn't for the earth behind them, they would collapse on their own or get knocked over very easy. It's the terrace behind that's really important. This is just waterproofing. So, just paraphrase Mike Haddock, there are two types of retaining walls, ones that are going to fall over and ones that have fallen over. And it speaks to the skill of the Inca that they were able to build these walls and that they last for so long. The amount of force, as gravity pushes the dirt and water gets in, even really strong walls, retaining walls are going to fall over. But theirs have lasted really long, and that goes to the technology is the construction of the terrace. Nothing is supporting that wall from falling over. They tend to build at a 3 to 5 degree angle. Backslope, this is a common feature in all Great Wall builders, Romans, Greeks, Persians, and so forth. That's, in Japan, recent video I showed on those masons, they're rebuilding an old wall as well. Cool picture of a restoration project in Lalipata, just about a kilometre to the west, and an interesting method of, like you don't need lasers to do this. Build a frame and a string line to guide the build. Sticks and strings, but again, the organs and the spine, the skeleton that made Inca possible was this terracing in the country, using earth and water to build their civilization. So it's not just the terrace of the farms, it's also the road, huge road system they built as well. Here's an old comparison between what it looks like now and what it looked like back, I think, 1905, could be in the 1920s, but yeah, this place has been really tidied up, and there was a lot of destruction, quarry work going on. Probably, even noticed a hill in the background. This also applies on another hill that I showed a little bit earlier. I didn't mention it, but I think there's a lot's been going on in this place, whether they was a sand mine or to build for concrete or whatever. Quite a bit of stuff's happened. So that's sections 26 and 27. You can use this stone as a reference because we see it there. So it's what it used to be like and what it's like now. Now this is an aerial view. Again, you can see the saw-toothed pattern. And the question is Sacsayhuaman, was it a fortress? Let's look at the geography. So up to the north here of Cusco we have Tambo Mache. Tambo, as in Olante Tambo or Tambo Mache. It was basically a storage facility. So where soldiers, workers would store their equipment and that type of thing as well. But it's also, this place is essentially a fortress as well, because it's looking down. This is the old road. See, there's one platform and one platform on the other side. Did it serve a religious function, social function as well? Almost certainly. But it also was an important point because it guarded the road coming into Cusco. I just highlighted the roads there, and just like with the old Roman roads in Europe, the old Inca roads are still in use today because they just, it was convenient to build there, but also they knew where to build their roads because they knew a thing or two about road building. And so from Tambo Mache, that road leading into Cusco passes through and near Sacsayhuaman. So now Sacsayhuaman is, Tambo Mache guards the road, Sacsayhuaman is guarding these other roads coming into the city. From there, I'll see a bit in a moment, but there are steep hills on this side. So you get it's a high view, so you get an excellent view over the city, across to the other side, but also the approaches to the city as well. Perfect place to put a fortress. So there's, I've just highlighted those in red, the sawtooth walls, and that's that part there. So multiple tiers, multiple levels. So protecting the city from the north. And it is, these walls would make a great fortress. Not so much if you're using slingshots against guns, but even then, still great fortress. Now, of course, they're attacking the wall from the north and attacking the main wall. Well, that's great, but that reminds me, so I thought, no, this can't be a fortress, because I'm so used to see, of most presentations, documentaries only focus on this part of this particular site. So it would be a great fortress as long as they agree to attack from that particular angle, which made me think of Maginot Line, French built to defend against any German invasion. Especially after World War I, they built this really strong line, but along the German border, but the line of defence along the Luxembourg and Belgian border not so strong. So instead of attacking at the strong point where the fortresses were built, the Germans just went around. And so these walls would be great. We'll just attack them from the side, but a little bit further investigation. So there we see again these really steep sides and then we have the wall going across, but let's just have a look at that. So from the north, great defences. However, I was able to get on from Google Earth, so you can see the westerly side. Again, so much of the stone has been removed, but we see multiple levels of stone walls. Now, if you were to add palisades, say like big spiky, sticks sticking out and fences and stuff, that would even strengthen it even more so. Alright, so on the southern side, again, lots of levels of walls built there. Even with only traces of it left, you still get an idea of the defensive potential. There's a great lookout here as well, and again you can see the walls of stones being mostly stripped, but was there. And on the eastern side, and the stones have been stripped out, but layers, levels of defence. So there's another bank over the top here. So that's where the photos show it. Now I'm almost certain that there was, where I couldn't get the photos of it to fill in those gaps in between. So it's encircled by stone walls. So you could fill in those gaps. So whether it's an Iron Age hill fort, controlling means of, roads and rivers, control the communication lines, got a good height so you get a good view, you can see people coming from a distance, multiple layers of defence. So even if they crack the first bank, well, they got to do it all over again and again and again until they get to the top, which was the same principle in medieval castles, layers of defence. Alright, so Sacsayhuaman, it would be difficult to design and position a better fortress.
There we have it. Pretty conclusive, I think. What do you reckon? Do you still have any questions? If so, please mention them in the comments below. And as always, please remember to like, share, and subscribe to help us out. Thank you for watching, and catch you later.